Hi, I'm creating a series of Rust tutorials actually in order to understand how exactly Rust works, and it might be beneficial for you as well if you want to learn Rust. So first and foremost, what exactly is the adoption of this language across the community of developers is something I'll like to present. JavaScript, being one of the most popular languages across the developer fraternity, as it ranks top on the Stack Overflow polls actually. But you can see Go and Rust are not far behind. So these two languages are set to replace Java as well as C++ in coming days. And if you could see, Go is a little more popular than Rust, but I believe both of the languages have their own benefits and their own drawbacks. Within this series, I'll maintain this Notion doc and I'll keep on updating it whenever I release a lecture. And the notes, you could find it here. I'll attach the link of this Notion doc and all the videos. The first and foremost topic which I want to discuss is to provide you some motivations, or if you want to understand why we should learn Rust, is memory safety without garbage collection. So uh, if you have worked with Java or Go or even C++, memory management is a big issue. C++ is quite more more easier or more compatible if you want to allocate memory to a specific portion of code or inside your application. But in Java and Go, they have a built-in feature called garbage collector, which is responsible for freeing up memory whenever an application is running. But in case of Rust guarantees memory safety at compile time using ownership and borrowing rules. So there are no null pointers, there are no data races actually. This is quite similar to what we have in C++, but it is more stricter than C++, I would say, and more precise. You won't have any null pointers, or you don't have any unhandled exceptions or unhandled scenarios actually in Rust. So it's a big advantage. You'll come across this when we start the hands-on lectures actually. Another point is concurrency in Rust. So if you have worked with Go, Go also handles concurrency in a very good way using Go routines, but it does not prevent race conditions. Whereas Rust has prevents data races at compile time itself. Neither Java nor C++ can do it. So concurrency is one of the best features which Rust provides. In case of error handling, if you have worked with C++ or Java, you might have handled exceptions as well in try catch blocks. Now it is quite verbose, and you'll have to keep on throwing exceptions across the whole layer if you are working in Java or C++ applications. But Go simplifies it a little bit. You can have multiple arguments which are being returned from a specific function, but still you'll have to handle the exceptions explicitly, which makes it very verbose as well as less expressive. And also it lacks algebraic data types actually. Whereas in Rust, what you have is you have two different enums resultant options which can handle errors explicitly without exceptions and panics by default. It makes our job much easier. So Rust enforces thoughtful error handling without being like verbose like Go. So that's one of the advantages which I think is making Rust a better one. If you talk about adoption, there are a number of companies which have come to adopt Rust because they basically want to reduce their latency across their platform, and they want to design applications which have very less latency. And Rust being one of the most popular languages for reducing latency, it is quite adopted in companies like Firefox, Dropbox, Cloudflare, AWS, Meta, and Microsoft. So if you talk about future potential, I guess blockchain and cloud native development or even embedded systems, it is going to get more popular in coming days. One of the first and most exciting parts of learning Rust is Web3 and blockchain development. Uh, if you talk about performance and gas efficiency across Web3 applications, it basically reduces the gas cost. So gas cost is something, if you're making a transaction, say suppose buying a Solana or selling a Solana across a crypto network, the gas cost is the amount of money which you are being charged for that specific transaction. Now in case if you want to reduce these gas costs, what you need to do is you need to lower down the latency of the systems. And I guess Rust is one of the prominent languages which is going to reduce the latency by a big time. especially chains like Solana or near Rust smart contracts are compiled in WebAssembly, and which offers blazing fast performance and lower gas costs. Go and Java don't have such mature WebAssembly targets, so the cost is not that low as compared to Rust. So Rust being one of the most popular languages in Web3. With respect to security as well, Web3 bugs. If you are building up a crypto exchange and you have some issues with a smart contract, it is going to cost you millions or billions, because there are people doing transactions every day and night on your exchange. So Rust is a programming language which does not involve any undefined behavior, which reduces the risk of bugs quite massively. And it also provides you compile time guarantees, so it is much more secure than any other languages right now. It is widely used as well. So if we see the ecosystem, like Sonara smart contracts are written in Rust, Polkadot, runtime logic and custom blockchains are authored in Rust, Near protocol contracts are written in Rust, compiled in WebAssembly. Even Ethereum is Rust based tooling, like is using supports of Rust based tooling like Zinc and Fuel. So I guess Rust has quite a good amount of adoption, and it is worth learning it. One suggestion which I want to give you right now is I prefer using a laptop on the hands-on tutorials going forward, and if possible try to make as much as notes, because you can't visit the videos every time. It is better to have notes, and these notes will be available to you on the Notion doc as well. So but if you have written something in your own language, it makes much more sense once you go back to it. So yep, looking forward to more hands-on tutorials in the upcoming lectures. And yep, thank you for listening. See you in the next one.